See, here I have given you some set of questions, and these questions, if you solve them, they'll be helpful in solving the questions related to paging. So I'll explain you what I have given here. See, now I have given you here what is logical address space. Logical address space means the process size, and physical address space means the memory, right? Main memory size. And then logical address means the number of bits required to represent the to identify or address the logical address space. And physical address means the number of bits required to address the main memory. And then page size you know anyway. And then page offset is number of bits which are used to represent, which are used to address the bytes within the page. And pages, frames, pages means the number of pages in the process, right? And frames means the number of frames in the main memory. And page table entry means once you design this, once you come up with the page table, we are going to put some entry in it, isn't it? And what will be the size of the page table? That depend on the number of pages in the page table multiplied with page table entry. And mostly what will be present in the page table entry, I told you already, right? So the main important thing is frame number. Along with that, some extra information could be added, right? So if they don't give you anything about what they are going to add, or if they don't tell you anything, just take the frame number bits, which means number of bits which are used to identify the frame number is going to be present inside the page table entry, right? Okay, now watch it. See this first. Logical address space is 128 KB and physical address space is 128 KB. Then what is the logical address? You do the math. See, you please have a notebook with you and you please do the rough work on that. I'll just directly do it here. See, now if logical address is 128 KB, and one more thing, in this entire question, I'm going to assume that each word is 1 byte and your system is byte addressable. So I'm not going to take anything about the words. I'm just going to take everything about the bytes. Okay. So the system is completely byte addressable. So whatever I'm going to talk here, explain you this, it could be even extended to the concept of words. So sometimes what happens is they'll give you every information required. Along with that, they'll even say that a word is going to contain so and so bytes, right? Then you convert everything into words and then solve the question. Got it? So what is that I'm here going to do is assuming that it is byte addressable, which means one word equal to 1 byte. And in case if one word equal to 2 bytes, then you divide by 2 and convert it into words, and then you talk about the addresses. Before talking about the addresses, just you should be always be clear what is the smallest addressable unit. That is nothing but the word. So before you talk about the addresses, convert every address space into the into number of addressable units. If the addressable unit is 2 bytes, then convert the entire address space into 2 bytes, 2 bytes, 2 bytes each. That is nothing but the word. Right? You understood this? Okay, let's go ahead. Now watch it. So logical address space is 128 KB and physical address space is 128 KB. Then what is logical address? So logical address is, you have to apply log to this. You know this. What is 128? 2 power 7. What is K? 2 power 10. Therefore, logical address is 2 power 17. Right? 128 is 7, 2 power 7, and K is 2 power 10. That is why it is, okay, this entire thing is 2 power 17. Then what will be logical address? Logical address will be 17 bits. So 17 bits are required to address any byte in our process, right? And similarly, this here also we have 128 KB, therefore physical address will also be 17 bits, right? And then what about the page offset? Page offset is nothing but number of bits which are required to address a byte in the page. So this depends on the page size, and the page size is 4 KB, right? If page size is 4 KB, how can you write 4 KB? It is 2 power 2 into 2 power 10, which is nothing but 2 power 12. Therefore, how many bits are required in page offset? 12 bits. Got it? Fine. Now, what is the number of pages? So you could find out the number of pages. See, pages will be present in the process, isn't it? You can find out the number of pages by taking logical address space and dividing it with the page size, isn't it? So logical address space consists of pages into page size, right? So if you want the number of pages, you take the logical address space and you divide it with the page size. See, in fact, logical address space can be written like this. Logical address space equal to number of pages, isn't it, into page size, right? Why? Because if you observe the logical address space, it is nothing but dividing the entire logical address space into number of pages, and then each page is going to be of some size. That is why logical address space is number of pages into page size, right? So now you are given the page size and you are given the logical address space, and you are being asked what is the pages. You can divide them, right? Or the other way is, if you have logical address and if you have page offset, and if you subtract from logical address this page offset, then you will get the number of bits required to represent the page number. Why? If you observe the logical address, I written it like this. I divide into two parts. One is page offset and other is page number, right? And here you already know that this is the logical address, right? So from the logical address, if you subtract the page offset, then the remaining bits is going to be the page number. Now if you get the page number, that is nothing but then from that you could directly find out number of pages. If these many bits are required to represent a page, then how many pages will be there to power that number, right? So now from this logical address you subtract this. So 17 minus 12 is 5. Therefore 5 bits are used for page number field. Therefore it will be 2 power 5 pages. Or the other way is, you take this one 128 KB and you divide with the page size, then you get 32, right? So how? 128 is nothing but 2 power 17 and page is nothing but page size is 2 power 12. Therefore again you get 2 power 5. You can do any way, right? And similarly, not to find out the frames, you can observe that physical address is consisting of two parts, right? So if you observe the physical address contains two parts. One part is frame number, and other part is page offset or frame offset, isn't it? Therefore from the page address, right, if you subtract from the physical address, if you subtract the page offset, then you are going to get the number of frames, which here is going to be 2 power 5. Same. The reason is simple. Both the physical address space and logical address space both are same, and the page size and frame size both are same. Therefore you will get the same number of pages and same number of frames. Nothing to do in that, right? And now what will be the page table entry? Page table entry means once you form the page table, what is that you are going to write in that? The frame number, right? And if you have 2 power 5 frames, then how many bits are required to represent a frame? 5 bits. And these 5 bits will go into the page table entry. Got it? And then last one is page table size. So how can you find out the page table size? Number of pages. The page table will be as big as number of pages in the process, and then each entry will contain some amount of some bits, isn't it? Therefore how many pages are there? Number of pages is going to be 2 power 5, right? And 2 power 5 into size of each entry is going to be 5. This is in bits, right? If you want to convert into bytes, you can convert it, or if you want to convert it into words, you can convert it, right? In case if they have given you words. Understood this? Therefore the page table size is nearly 2 power 5 into 5 bits. Now what will be that size in bytes? Divide it with 8. I think you are going to get 20 bytes. I think so. Okay, you just guess it, you just see it. Fine, that is all about it, right? And let's look at the next question. Next question, they have given you logical address, they have given you physical address, and now you are supposed to find out logical address space and physical address space is given. You are supposed to find out logical address and physical address. Then you are supposed to find out page offset, number of pages, number of frames, and then everything. Same as the earlier one. But the only difference is here they have already given what is a page table entry. You need not compute it now, isn't it? If they have given you the page table entry, don't compute it. The reason is they have already kept that frame number, along with that the extra bits required, everything is already present here as 2 bytes. So you have to just compute the number of pages and then multiply with the page table entry. Right? Now watch it. Logical address space is 256 KB. Then what will be logical address? See, 256 is 2 power 8 and K is 2 power 10. Therefore, it is going to be 2 power 18. So, how many bits are required? 18 bits, isn't it? And what about physical address? 1 MB. And 1 MB is nothing but 2 power 20. Therefore, how many bits are required in the physical address? 20 bits, right? And now page table size is 4 KB. Then what will be page offset? Same. So page offset is nothing but 12 bits. Why? 4 KB is 2 power 12, and therefore page offset will be equal to 12 bits, right? And what about number of pages? So if you watch for the number of pages, you could follow the same method. What is it? From the logical address, right? You subtract the page offset. So if I subtract it, then what do you get? From the logical address, if I subtract this page offset, it is going to be 6. Therefore, number of pages is going to be 2 power 6. Always remember this, logical address will always be greater than the page offset, right? The reason is logical address, should at least contain these many pages. Okay, I'll talk about that later. This constraint, I'll talk about it later. Okay. And next one is number of frames. So watch it. So number of frames is, in order to find out number of frames, you have to take the physical address because it is related to the main memory. From physical address, you subtract the page offset, right? So from this you will subtract this. What is it? 20 minus 12 is 8. Therefore you get 2 power 8. 2 power 8 frames are there. Getting this? 20 is the physical address and page offset is 12, and 20 minus 12 is 8. Which means the number of bits used to represent the frames is 8. Therefore, the number of frames will be 2 power 8. Got it? And now, what about the page table size? Already page table entry is given as 2 bytes, which means every entry is going to take up 2 bytes. Then how many entries will be there in the page table in total, right? So that depends on this one. So if the page table size is page table size depends on the number of pages. So how many pages are there? 2 power 6 pages are there. 2 power 6 pages, and each one size is 2 bytes. Therefore it is 2 power 6 into 2 bytes. It is important. Earlier it is bits, because earlier the number of bits represented, the number of bits used to represent a page table entry was 5 bits. Therefore earlier it was bits, now it is bytes, right? And now look at the next question. So in the next question, logical address space is given, but physical address space is not given. So in order to compute the physical address space, they have given something indirectly. So one thing is, they are saying that page offset is 10 bits. If page offset is 10 bits, then what will be the page size? Then page size will be 2 power 10, isn't it? That is how you get 10 bits as page offset, right? So page size is 2 power 10 and number of frames is 256. And you already know that page size is equal to frame size. That is always there. Now page size equal to frame size, and therefore the frame size is 2 power 10 bytes and the number of frames is 256, right? And you know that already physical address space is nothing but number of frames into frame size, isn't it? So number of frames is 256 and the frame size is 2 power 10. Yeah, where is the frame size? Yes, frame size and page size both are same. Number of frames is 256 and the frame size is 2 power 10. Therefore, what will be physical address space? Multiply both of them. 256 into 2 power 10. So, which is nothing but 256 KB. Isn't it? 2 power 10 is K. That is why I have written it like that. Understood? Okay. And now, after finding it out, I think everything is straightforward. So, what is logical address? Logical address will be depending on this, which is 20 bits. And what is physical address? Physical address will be depending on this. So it is 8 and it is 10. So it is 18. Physical address will be 18 bits. Isn't it? And now what about the pages? In order to get the pages, you take the page offset and subtract it from logical address. So if I subtract it from logical address, what do I get? 20 minus 10 is 10. Therefore number of pages will be 2 power 10. Right? And now what about the page table entry size? So in order to find out the page table entry size, you should find out the number of bits which are used to represent the frames. Now the number of frames is 256. Therefore, how many bits are used to represent the frames? 8 bits. So 8 bits is going to be page table entry. And what about the page table size? So page table size is going to be number of pages into page table entry. So what is it? 2 power 10 is number of pages multiplied with page table entry is 8 bits. Remember, this is bits because if you have this 2 power 8, 8 bits are used in the used to find out the frame number. That is why this is the answer, right? And next one is physical address space is 512 MB and page size is 2 power 12 and the number of pages is this. So now they didn't give you this logical address, but then they have given you the number of pages and the page size, and you know this, what is logical address space is equal to number of pages into page size, that you already know it, right? Then what we could do is number of pages, which is 256, into page size. You can multiply that in order to get the logical address, right? So if I multiply this is 2 power 8, this is 2 power 12, therefore it is going to be 2 power 20, which is nothing but 1 MB, right? Now logical address space is 1 MB, physical address space is 512, and you can fill it up, right? How? If it is 1 MB, logical address is 20. And what about physical address? 512 MB. So 512 is nothing but 9 and MB is nothing but 20. Therefore it is going to be 29. Isn't it? And what about page offset? So since page size is 2 power 12, page offset is going to be 12 bits. And what about the number of pages? Is already given. What about the number of frames? Now to get the number of frames, you have to subtract from physical address this page offset. From 29, if you subtract 12, it is going to be 17, isn't it? Therefore number of frames is going to be 2 power 17. Got it? And what will be page table entry size? Page table entry size is nothing but number of bits used to represent the frames, right? So how many bits are required to represent the frames? If these many frames are there, 17 bits are used to represent the frames, right? Then what will be page table size? Page table size will be number of pages, which is this 256, into number of bits used to represent each frame, which is 17, right? So 256 into 17 bits, right? See, this number of pages doesn't have any units, but then this unit, the number of bits, this one has units. 17 is having the units bits, and here 2 was having the units bytes. That is why it is 2 bytes, and all the others are bits. Got it? Okay, and now watch this one. Page size is given, number of pages is given, number of frames is given, and nothing else is given. Now how can you guess the logical address? Logical address is nothing but page size into number of pages, right? So if I multiply these two, I am going to get the logical address space. Therefore what will be logical address space? 2 power 22, isn't it? Then what will be physical address space? Physical address space will be again page size into number of frames, right? So it is 2 power 12 into 2 power 9. Then I get the physical address space. Then how much is this? 2 power 21, isn't it? And then what will be logical address? Logical address will be 22. What will be physical address? Physical address is 21. And what is page offset? Page offset is this one, page size, right? So from page size we get page offset, right? And then what about, everything is there. Then what about the page table entry? Page table entry size will be number of bits used to represent the frame, which is nothing but 9. And what about the page table size? Page table size is number of pages, which is 2 power 10, into number of bits used to represent the page table entry, right, which is 9. So these many bits. Okay, see, when I am doing it, I am subconsciously doing it. I am not doing it consciously. So if there is any mistake in this table, you please correct it and you use your judgment. So there might be a chance that I might have written somewhere, one number wrong, because I didn't. I'm just doing it subconsciously. I just randomly generated the numbers and I'm just using my subconscious mind. After teaching it for many times, instead of taking my conscious mind here, at least for this point, for this part, my subconscious mind is working, right? My conscious mind is thinking something else. Okay, so if there is something wrong, you please fix it. Now watch this last one. This is interesting. They are saying that page table size is so and so. They are giving you the page table size, and then they have given you number of pages. Is this going to be enough or something is required? Then it is going to give you number of frames. Pages is given and you will get the number of frames. Yes, one more information is required. So page size is also required. Let us say page size is 2 power 14, right? Now we could do it. So now let us say these three informations are given and now we are supposed to find out everything. So watch this. since the page table is given, page table size is given, and pages are given, what could you find out? See this, page table size is equal to number of pages into page table entry size, isn't it? Therefore, what will be page table entry size? Page table size divided by number of pages, right? And what will be this? Page table size is 256 bytes divided by number of pages. So how many pages are there? 2 power 8 pages are there, therefore it is 1 byte. So 1 byte is used in order to represent a page table entry. What does it mean? And they didn't say anything else, therefore you could assume that the entire page table entry, that is assumption, because they didn't give you any other thing, therefore if you don't assume this, you cannot solve it. So since they didn't give you anything, you could happily assume that the entire page table entry size is filled up with the number of bits which are used to represent the frame, right? So in this case, if 1 byte is used to represent a frame, right, then how many bits are used to represent a frame? 8 bits. Therefore, page table entry size is 8 bits, and therefore number of frames will be 2 power 8, isn't it? Why? Page table entry contains the number of bits used to represent a frame. If they are using 8 bits to represent a frame, then how many frames will be there? 2 power 8. Got it? Okay. Now, what about the page offset? Since the page size is 2 power 14, then the page offset has to be obviously 14. Fine. And now you can fill all the others, right? How can you fill the others? Logical address space is nothing but number of pages into page size, right? So number of pages is 2 power 8 and page size is 2 power 14. Therefore, what will be logical address space? You multiply these two. If I multiply these two, what do I get? I think 2 power 22. Okay. And then what about physical address space? Physical address space is frame size, which is equal to page size into number of frames, which means these two have to be multiplied. So it is 2 power 14, 2 power 14 into 2 power 8, which is 2 power 22, right? So which is nothing but here, if you want to write it in MBs, it is 4 MB and it is 4 MB. Okay. And then what about the logical address? Logical address is 22 bits. And what about physical address? Physical address is 22 bits. That's it. So this is how you could solve the questions. Fine. So using these, I think using these examples, I think I made clear how to solve the questions on paging. Okay, you can copy this. Okay.